Welcome to MEI Mechanics. We're on the topic of work, energy and power 1, work and energy, and this is video 1.4, potential energy. So we've talked about kinetic energy already, which is one part of what makes up mechanical energy, and the other part is potential energy, and that's mechanical energy which is due to the position of an object. So we can think of potential energy as energy which is stored in the object, and which gives it the potential to move and to become kinetic energy when released. So the two main types of potential energy that we're going to meet are gravitational potential energy and then elastic potential energy. We'll be focusing on gravitational potential energy in this video, and we'll talk about elastic energy, which is stored in springs and strings later. So all bodies with mass experience gravitational pull from the Earth, and we call the forces acting upon them as a result of that the weight, and that weight is proportional to the mass. Now that's something that we've already mentioned in an earlier video. So the weight is equal to m times g. G is that constant of proportionality. It's the also known as the acceleration due to gravity, and on the surface of the Earth it is approximately 9.8 meters per second squared. We've mentioned previously that it varies slightly over the surface of the Earth. It always rounds to 9.8 no matter where you are, but if you go into the next decimal place, then that decimal place can change slightly as you move across the Earth's surface. So 9.8 is a good number to use for that. Now, if an object is moving in a vertical direction, then it is moving in the direction of the force, or exactly against the direction of the force of its own weight. So there's a link here already to the idea of work. Remember, work is about distance moved in the direction of a force. So if an object moves up or down, then work is being done against gravity. It's being done against the weight of the object. And so by the work energy principle that we saw in the previous video, the object will have to either gain or lose energy as a result of that. So the change in the energy, the potential energy, when a object moves through a certain height, is essentially that work that's either done on the object or against the object as it makes that change in height. Alright, so it's the weight, which is the force, times the distance that's moved in that direction, which we call height, and because the weight is equal to mg, that means that the change in the potential energy is mgh when it moves up through a height h. So this expression mgh, we'll call this the gravitational potential energy of the object, and that's the energy which is gained whenever an object is lifted through a height h. And that energy that sort of stored energy has the potential to become kinetic energy if the object is released. So an example where you see this idea in effect is when you have hydroelectric power. So in this case we've got a dam which is holding back a load of water, so the water behind the dam is higher than the water on the other side of the dam, and so that water has got potential energy, gravitational potential energy. If that dam is released, or the water is allowed through a pipe in the bottom of the dam, then the water will rush out of it with some speed because it's got kinetic energy, and that can be harnessed with use of a turbine. Okay, so you're converting potential energy into kinetic energy and then into electrical energy. Now here's an example that we can use to test this idea out. So we've got a particle of mass 30 grams, and it is moved up a slope, so perhaps pushed up a slope, distance 2 meters up the slope, which is inclined at 60 degrees to the horizontal, and we want to find the gain in its gravitational potential energy as a result of that. Now the first thing to do is to work out the actual height that it is lifted to, because the 2 meters is a sort of diagonal distance, isn't it? So if we apply our basic trigonometry, we can see the angle here is 60. H is opposite that angle, so H will be 2 sine 60 degrees, and that turns out to be exactly the square root of 3. Then we want the gain in its gravitational potential energy. Well, that depends on the mass and the height and on G. The mass is 30 grams. It's probably worth remembering to write that in kilograms, so that's 0.03 kilograms. That's the value we should be using. And so the gain in the gravitational potential energy, often we use this symbol delta to mean the change in something, so that's a nice little shorthand for, in this case, the gain in the gravitational potential energy. So that is mgh, so it's 0.03 times 9.8, because that's the value of g, times the square root of 3, and that is 0.51 joules. Note that I've only used 2 significant figures there, and that's because any calculation where g is played a part should really only be given to 2 significant figures, because g is only being used to 2 significant figures. So we're going to look at another example now. This time we're dealing with a situation in which an object is released and is in free fall, and so we're going to be dealing with gravitational potential energy, which as the object falls is going to be converted into kinetic energy. First thing we're asked for is the change in the gravitational potential energy, and we know that that is mgh, where h is the change in the height. Alright, so we need to be careful here. We know the mass is 5, we know that g is 9.8. The change in the height, we're thinking of the height being measured in the positive direction, is minus 10, because it's falling downwards. So that works out as minus 490 joules. Alright, so that's part 1. Part 2, the kinetic energy at the instant it hits the ground. Okay, so it's released from rest, so at that point its kinetic energy is 0. As it loses that gravitational potential energy, that is being converted into kinetic energy. So the amount of kinetic energy it gains is equal to the gravitational potential energy that it lost. So that is just positive 490 joules. Now what about the work done by gravity? So we're thinking about the change in the kinetic energy is going from 0 to 490 joules, and that's because work is being done on that object by gravity in the direction in which it is moving. So the work that's done on the object by gravity is also positive 490 joules. So that concludes video 1.4, potential energy. The final video, 1.5, will be conservation of energy.